Alright, so next step is to take that FET out. I pulled my one of my soldering systems over from the workbench over there where I do most of my rework. And I'm going to pull this out. It just takes a few seconds. You heat up all 3 pins at the same time, and it comes right out. The reason I do that is because the amount of time that I'm heating up the pins, now obviously the part doesn't matter because it's ruined, but the traces on the board and the pads around the pins, they'll lift without any provocation whatsoever. So you want to be on them and off them as quick as you can. Now not everybody can have an expensive system, but another thing people do is you take solder, and obviously the thing you're working on is not powered up, but you fill solder in on all 3 joints. You fill it in so it's one giant solder blob, then you can use any kind of pencil or anything you want, heat them all up, yank it out. Lots of ways to do the same thing. So let's check this bad boy. The center pin and the heatsink are the same pin, so I'm going to check here. Definitely shorted. Oh yeah, shorted, no good. So this one says it's made by Fairchild and it's an 18N50. So if I remember my nomenclature correctly, that's 18 volts, no, 18 amps, 50 volts. So, okay, so that one's toasted. So if we check here, it's totally open. Yeah, so okay, that was the source of that short at least. Let's go check the diodes on the other side. I lifted this up, the board up with this, the top part of the heatsink here, so that I wouldn't burn my towel. I finished this bench myself years ago, and I don't want to get it scratched up with all this metal, so that's what this maroon colored towel's down here for. Okay, so let's take a look at our diodes. Yeah, they're all doing good. Now, you could very well swap your leads and do it the other way. The problem is if they're shorted, the short does not have any polarity. It's shorted. So anyway, either way, all the diodes are fine. Okay, so far this guy has an open fuse. And I think if I can get my fingers in there, it's these 2 pins right here. And it pulls right out. So that, yeah, see, it's all smoked under there. See that? Nice and blacked out. So this thing went poof. So my next step is alcohol and Q-tip. Clean that bad boy up. Yeah, I think it scorched the board just a tiny bit. Or maybe that's maybe it was glue on there before, but okay, so now that's nice and clean. Now, that seems to be all that I can find on here. I checked both fuses, all the diodes, all the FETs in both sections, AC and DC. Let's see, are the gate resistors on the bottom? Shoot, where are they? So that means they gotta be on the top. Right. I want to find especially the gate resistor. Oh, these are actually labeled. How funny. GDS, gate, drain, and source. Literally labeled on the board. I saw somewhere on YouTube that there's an instruction video. Oh, look, there's test points. Okay. There's an instruction video. They say actually in the instructions how to replace these parts. Okay, so the gate is attached to this diode. Now, what the diode does is it keeps the gate from, hang on a second here, let's see if this diode's got a short to it. No, it's good. Okay. Yeah. You can check it on the diode mode of your meter or just resistance, either way. The reason I don't tend to use the diode mode is because you're actually putting voltage out into your circuit. You are with this too. Okay, so I don't really see anything terribly wrong. There's a lot of flux residue in this thing. That's from saving money. The problem is, it depends on the flux they use, but you see, this is, you can't see it on camera, this is all filled in with flux. And flux, as it hardens and gets old, becomes just slightly conductive. Now these circuits aren't high frequency, so I probably won't change anything, but I don't want to beat on everybody about cheap workmanship. Now this one I wasn't getting a reading. Oh, it's just crap on the board I can't get through. Yeah, so, alright, so the diodes are fine. I'd really like to find out where the resistors are. There should be gate resistors here somewhere. Okay, well, they're not. Okay, here we go. This gate right here, there's a resistor right here. 10K. Wow, 10K for a gate resistor? Really? In my experience rebuilding motor controllers, this gate resistors are between 10 and 150 ohms. So, nope, 1002, that's 10K. Wow, 10K for a gate resistor. Wow. Well, the good news is, when you use something that incredibly high, that when the FET shorts, that shorted power is going to have a hard time getting through the resistor and into the processing circuitry. So it may, in the long term, save itself. I got this damn grease on me, so I got to get it off before I smear it all over everything. Okay, so I want to check these gate resistors because in all the motor controllers I ever rebuilt, a huge portion of them went out. So, okay, here's two of them. That's 10K. They're hard to read. 4 digits is implies higher precision. Okay, so we got this one and this one. And man, I just don't see. I see a 10K here. I wonder if. Yeah, that's tied to it. Whoa. Okay, so this one that we pulled out that's dead, here's the gate lead. It goes through here and it's tied electrically to right there, to this end of that resistor. And then when you check it, this is a, looks like a 1003. So just in case you don't know how to read resistors, 100 and then 3 means add 3 more zeros to that. Oh shit, those are 100K, not 10K. Wow, okay. Man, that's the biggest gate, the highest value gate resistor I've ever seen. But, well, that's 90K. That's within spec when you're putting it. Oh, okay, these are down here are 1002s. Okay, so that's probably not the gate resistor then. Let's flip it over. Let's see if we see any small resistors here. I do not. Huh, I don't see them. I want to find the gate resistor for this guy because it might be blown. Well, see, that one does. It goes right to this 10K right here. I see it's tied to these two transistors, usually what the two transistors do is they pull the signal up and pull it down, forcing it down so it makes a real clean square wave, but or whatever waveform you're applying to this. Shoot, that says 10K, and it's 10K. Well, that's just me getting familiar with the circuit, but I don't see what I'm looking for. So if if these other ones are using 1002s or 10K, then all of them should be. They should all be the same. And I just don't see it. Okay, so let's go in with the loop here and look for 1002s. Sorry, I'm taking the time for this, but I don't know the circuit. I just know that these drivers all have basically the same failure, whether it's in a an inverter like this, motor controllers, they all pretty much have the same failure. But gosh, using 10K resistors. Okay, got that resistor's there, this resistor's right there, this one goes to that pad there, which moves over to here. Well, you can only go with what you see. It looks like they actually might both be 10Ks on these other two transistors, so okay, fine. And that's how it is. You always want to check that because you'll put this thing back together and you'll blow the FET up if the gate signal's not doing its job. Alright, so I'm pretty happy that right now that's all that's wrong with it. So one thing I always do, because my repair technique style, if I can find my solder, is using these wide tips, these solder tips. I don't remove the solder out of these holes because you can damage the pads, heating them up so often. Because remember, this is inexpensive circuit boards. So what you do is you add solder to each one so that you can heat it up and drop the FET in. That'll come much later. Alright, so we're going to call this good for now. What else makes sense to check? Let's see. I think that's about it. Oh, the fuse. Okay, so what we got to do with the fuse is I don't know what the value is. Oh, let's see. 5 amp, 250 volts. Boy, that's some intricate writing. Oh, you know what that probably is? It's probably laser etched. Okay, so I need a 5 amp 250 volt fuse. That's not a big deal. I may have to rig another type in there because I don't have anything like that, and I really don't want to order parts for something that costs so little, even when it's fixed. Okay, so what I'm going to do on this one is I'm going to test this other one, and we'll see which one's broken the least, and then steal parts off of one to test the other. Because at some point, obviously, I'm going to have to buy some parts, but I'd like to know that I can at least get it running with what I have here. So fuse, 5 amps. I think I have a calibrated fuse here somewhere. Some people are going to have a fit for me doing this, but don't worry, I'm a professional. Okay, so, God, after I use glasses, man, then I'm half blind if I don't. Alright, so what I'm going to do here is take this and this is 32 gauge wire that I've had. I've literally had this wire since my grandfather's days, and I'm going to just literally solder it across there. and that'll be my fuse. It's 32 gauge. Yes, it's probably not the appropriate fuse, but to test this, this is what we're going to use. So I'm gonna... Now this is for testing. I'm not going to leave this in here once it gets running. Yeah, sure, no, I really am not. Because when it comes to AC stuff, you don't want to screw around. Okay, there's one. Okay, there's two. Alright, so, I'm going to trim this off. Alright, so, yeah, don't jump on me. Okay, this is temporary to test this thing. Piece of 32 gauge wire across there. It should be okay. I may have to touch the solder up a tiny bit, but there we go. Okay. So now we have that in place. Now we got to check the FETs. So this one is just missing a FET. There's not much I can do about it right now. So we will take this and put it out of the way, which I think we will just lay it across like this. This bad boy, this one has got a whole problem here that we've got to look that up. Look that over in the microscope. Yeah, that one's going to take a little while. So I'll come back because that was a lot of detail and I don't want to waste you guys' time on this.